All right, so in this video, we're going to do everything that we've done this chapter, but with the natural number e. So e is a special number in math. It's called the natural number. If I remember correctly, it was developed by Leonhard Euler, and he came up with this number. It's like a ratio that just occurs naturally. If I remember right, it has to do a lot with no, that's something else. Never mind. Anyway, you can look that up if you want. And anyway, this is e right here. So it's a lot like pi. Remember, pi, good old pi, 3.14, and it keeps going, never repeating, never having any pattern to it. So it's called an irrational number. So e is the same thing. This is an irrational number. But when we estimate it, maybe we'd say like 2.72 or something like that. So it's just a number that occurs, and a lot of times it gets used with logs and exponential functions, right? So for instance, if you have a graph of y equals e to the x, right? So this is just like saying y equals 2.718 or 2.72 to the x, right? So it's just a growth function. It just has like this base of e. So you see this a lot in calculus and so forth. But if we were to graph this, if you plug in 0, you still get 1, right? And it basically has all the same properties as a normal exponential function. It has an asymptote at y equals 0. And it just, comes across. It's a growth function because the base is bigger than 1. Okay. And then we also get a natural log. And then, this one over here, you can move it around. Just, if this had like, e to the x minus 2 plus 1. So if you had that function, you move it right 1 and up 1, or right 2 and up 1. And so it does all the same things that we've done before. With a log function over here. So remember that when you have a log function, you write the word log and you put your base. Well, log with base e, 2.72 of x, right? And so this is just shorthand. So that's called, since e is a natural number, this is right here standing for natural log or log natural, all right? So these two things, like, writing it like this is the exact same as writing it like that. It's just that, obviously writing ln is a little bit faster than writing log base e, right? And so when you graph it, it still has a vertical asymptote at x equals 0. And, you still have your basic log function where if you plug in 1, you get 0 and so forth, and it just rises over here and comes down over here, right? And then again, you move it around if you want to. So let's say you had, ln x plus 2 minus 3, so you'd move this graph left 2 and down 3, right? So it just acts the same as all the other ones that we've done. All right, so you can do the same thing, like if you have to expand or condense. So let's go ahead and do these. So recognize that I have in this problem two parts basically, and I'm going to break this into 2 logs, right? So I'm going to have ln of e to the third. Well, the 3 can go up front, and it's division, so I do subtraction. So minus ln. Now this 5x minus 2 has a 4th root. So remember, that's a 1/4 power. So I can write 5x minus 2 and then put a 1/4 out here. All right, so this is basically done, but this guy. So ln e, let's look at that a little bit. That's log base e of e. And remember, whenever these two things match, your answer is equal to 1 because e to the first power equals e again, right? So you can basically wipe this out and just write a 1 in its place. So that's what I'm going to do here. So this means this first part is 3 times 1, so that's 3 minus 1/4 ln of 5x minus 2. Okay, so there's my final answer. All right, if you don't do that, so like, if you don't reduce this, that's kind of like when, you would see something that says, oh, that's 5/10, and you don't reduce it to 1/2. It's just kind of silly not to replace it. All right, so over here, we're going to condense this. So this is 3 different logs, so it's going to have 3 different parts. And I'm going to put this 4 up top, put this 2 up top, and this 1/3 goes up here. Okay, so it's all addition, so it's all going to be multiplication. So 4 squared is 16, and then I have x to the fourth, so I have ln of 16 x to the fourth, and then basically the cube root of 5x plus 2. Now whether I wrote it as a cube root or wrote it like this, it doesn't really matter. I mean, it's just a matter of choice. Okay, and there we go. All right, so you're still going to also be solving equations with natural logs and also exponential functions over here on the end. So when you have a log equation, so look at these two log equations, log, 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 these all have logs. So that means I'm going to condense these and then put that 2 up here, and then I'm going to drop the word log and just solve what's left. Whereas over here, I have numbers and a log. So that means I'm going to get this guy by himself, move all the numbers to the other side, and I'm going to write it as an exponent. So I take away 8. I have negative 2 ln x equals negative 12 divided by negative 2. So I have ln x equals 6. So sometimes I like to do this. I think to myself, oh, ln, that means it's base e. So that helps me remember, oh, I can write this as an exponent, right? So I can write e to the 6th equals x. So, oh, why did I write an x? E to the 6th. So there's my answer. X is e to the 6th. All right, over here, I'm going to have to condense these. So I have, let's see, ln of x plus 3 times 3x minus 2 equals ln. I have to take 2x and square it, so that becomes 4x squared. I feel like I did this in one of the other videos, but that's fine. So now that we have condensed logs on both sides, they're both logs, so I can kind of drop this log part. All right, or basically I know that this has to equal that. So if I multiply the left side out, I get 3x squared, let's see, minus 2x plus 9x, so plus 7x minus 6 equals 4x squared. I'm going to bring everything over to the right so that the x squared stays positive. So it becomes 1x squared, the 7x turns negative, and the 6 turns positive. We did do this before. All right, so factor into 1 and 6, both negative, make a positive 6 and add up to negative 7. So my answers are 1 and 6. So you just do a quick check. It is a log equation, and I should have done that here also, but e to the 6 is positive, so it's fine. Over here, if I put a 1 or a 6 here, it doesn't make this negative or 0. Put a 1 or a 6 here, doesn't make it negative or 0, and same thing here. So we're going to keep both those answers. All right, on these last two, these are exponential functions with the base e instead of a base like a 2 or a 5 or something like that. So I'm going to isolate. I'm going to take away 5 from both sides. All right, I have e to the x minus 3 equals 2. And you have an exponential function that you can't solve. You're going to write it as a log. So I would write this as log base e of 2 equals x minus 3, right? Because that's what my problem says. E to the x minus 3 equals 2. That's what this says. So remember, log base e. Hey, guess what? That's ln 2 equals x minus 3. So I'd add 3 to both sides. So whatever ln 2 and then plus 3 would be. All right, and so then you would just go to your calculator, right? You'd, if you wanted a decimal for an answer, or you could just leave it ln 2, close your parentheses, and then plus 3. So if you needed a decimal, there it is, or you could just say ln 2 plus 3. All right, on this last one, same idea basically. We're going to isolate the e to the x, or e to the 5x. So take away 8. So I have negative 6 e to the 5x equals negative 18. Now, one problem here, if this negative, the negative 18, if that doesn't turn positive, then this would be impossible, right? Like if I got a problem that said like e to the 5x equals like negative 4 or something like that, you can't do that, because if you'd had, log base e of negative 4 equals 5x, you can't do the log of a negative. There's no such thing. So if this happens to you, you know that one is no solution. But in our case, it's not, because we're going to divide by negative 6. We get e to the 5x equals 3. And then I do like I did. So I'm going to write log base c, which is ln. So ln of 3 equals 5x. So all I have to do is divide by 5. So my answer would be ln of 3 over 5. Or if you want to be extra, a little bit tricky here, remember that's 1/5 ln 3, right? Like if I write it a little bit differently. So you could write ln of 3 to the 1/5. You could write it like that. Or if you need a decimal, just go to your calculator. But any one of these three answers is basically saying the same thing. And there you have it.